It's basically a summary of some of the work that has been done, mostly in VP2, but we also have contribution from VP1. In terms of this, there is a lot of discussion about the uncoupling of berry ripening today. And we would like to see what has been the contribution of Innovine to the job, okay? And this is the list of all the contributors who gave me examples, data, and they put everything together trying to get the overall picture. This slide doesn't have anything to do with Innovine, of course, because this slide is from our friend Nick Ducuzlian from Gallo, but it's interesting because it gives us a good idea of the complexity of the ripening pattern. Because you see, this is represented the ripening pattern for Cabernet Sauvignon with a rising sugar. And you see that there is a decrease in the veggie characters and an increase in the fruit character. But you also see that there is a plateau here and then there is a decrease again. So it's a very complex phenomenon. And so are we able actually to interfere, to modify, to change anything in this process? Are we able to maybe interfere with one process without changing the other processes? This is one of the questions. However, this is a too difficult question, I admit that. And so for having, let's say, a simpler question, I'd like to go down to this one, which is probably better. You see, this is a non-colored berry, right? This is Sangiovese, our beloved Sangiovese, okay? And so, but this is a soft berry. And so if you measure breaks on this soft berry, you get already 7, 8 breaks. But the color is not there. The color will come later. There is a fundamental paper by Brian Coombe, I guess, 30 years ago, something like that, showing that there is a delay of about 5 to 6 days between the rapid increase in sugar at the onset of color. So at this point, is this a decoupling or a coupling? I'm not sure. This seems to be a decoupling, and we would like to couple again. I don't know, but let's see what happens in terms of what we can do on this. Okay, now the problems here that in many areas we are actually experiencing too fast sugar accumulation, especially in red varieties, whereas the phenolics still lag behind that. Whereas in white grapes, in many cases, it's very hard to maintain adequate acidity, especially when you have a sparkling or spumante vinification ahead of you. But in general, also there is also a problem in terms of logistic. You need to bring grapes to the winery when the winery probably is not open or something like that. So it's a logical issue. And the other thing is, which are the objectives? Well, it would be nice if we could be able actually to decouple or couple, I don't know. So delaying sugar without delaying the rest of maturity is the challenge, I guess. And also safeguarding acidity without compromising adequate sugar level and aroma is another big challenge, I guess. Well, more in general, another goal would be decompressing maturity by delaying the whole annual cycle. Is that possible or not? A lot of people are actually working on this right now. So we have, of course, tools and techniques available for addressing the problem. Well, but before actually thinking about complicated solutions, maybe in some cases, we say, okay, we have a very fast ripening, but which is the reason? Well, in some cases, the reason is so simple that, for instance, you have an undercrop vine. If you have an undercrop vine, the ripening is fast for that reason. So the simple solution is maybe to leave more clusters on the vine, and then the ripening would go okay. So unless we are in this sort of trivial case, we do have tools to use. For instance, we can, think in terms of new genetic material, or maybe trying to use some existing biodiversity. We can also do some targeted leaf removal, or use of anti-transpirants, and then there is a final technique which is actually out of the activity of Innovine, but I will use just 2 slides at the end to just introduce the technique. Now, this is the beginning of the contribution by the partners. This is, you see, there is a yellow script here indicating the partners. So this is some of the data from people from Spain, where they were actually studying on the Tempranillo accessions, which were described before, the response, so you see, to two main temperature regimes. They subjected these vines, this is a number of the accessions that they were actually evaluating, and they created two different temperature regimes, 14 degrees Celsius day and night versus 18. So you don't see here very extreme temperatures, but there is a build-up, of course, over season in terms of accumulation, which at the end of the season is relevant, because every day you have basically 8 degrees higher in one case than in the other case. And you see, these are some of the data, very interesting data, I must say. You see, this is the number of days to go from fruit set to veraison, or from veraison to maturity. Well, of course, in general, not surprisingly, the number of days is lower in the higher thermal treatment than in the cooler one, although there is some variability, you see, within a given biotype, and in general, the effect seems to be larger for the fruit set to veraison. But the one kind of data I like very much is this one. When they plotted color versus breaks, you see that actually there was a nice separation between the two thermal regimes, right? But the beginning was similar, but again the slope was different, and you see that above 15 breaks you have higher color in the cooler treatment for basically most of the biotypes. That's a nice example of decoupling in general terms. And they also looked at the response of each biotype. As a matter of fact, there was also some variability. You see that some biotype responded very nicely, whereas some others did not respond very much. And there was also a variation in terms of variants having a short ripening cycle or a long ripening cycle. Indeed, there is very nice material here to work on. Well, another example is the one which Zhang-Wu just mentioned earlier in his talk. We have done some cooperative work with INRA and Zhang-Wu and Serge in terms of trying to characterize, the seasonal accumulation of sugar and color in two extreme treatments. We had, you see, a 12-leaf and a 3-leaf treatment. In other words, we wanted to create an extremely severe source limitation by just having only 3 leaves on a shoot with one cluster. That's crazy. And also we had the classic 12 leaves with one cluster. So a non-limited and an extremely limited treatment. And so when we plotted, well, actually when Zhang-Wu plotted the breaks versus the color, you see that the slope is dramatically different, meaning that when you have an extreme source limitation, the investment of carbon is mostly in sugar than in color. And my curiosity would be actually trying to investigate other values of this ratio and see what happens, for instance, when you also have an excessive amount of leaves per unit of crop. Because if we are lucky and we basically either stay in between these two or maybe higher, that would be probably a nice information to be used. Then more data from the group in Portugal. They were actually doing this interesting study, which has been recently published too, where they had two different water stress regimes, sustained deficit irrigation, regulated deficit irrigation, and they were also looking at responses on the west and east side of north-south oriented rows. Here you can actually see the major results. The decoupling due to the high temperature was higher on the west side, whereas RDE was more susceptible to high temperature versus the SDE. You see that actually the water stress was applied by giving a 30% ET water supply in SDI and only 50% in RDI. So it was a fairly severe water stress. Okay. Well, before I introduce the leaf removal, I need to go back for a second to a very old slide, from my PhD thesis. I'm proud of that. And where it is basically shown what is the, let's say, variation, the seasonal variation in photosynthesis of the different parts on a shoot, the basal, median, and apical part of the shoot. And it comes out that after veraison, not surprisingly, the apical part of the shoot, at least in terms of specific photosynthesis, is the one having the highest values because you have mature leaves. At the same time, those leaves are not really senescing at that time. So this is the principle we wanted to use by applying the apical to the cluster high leaf removal. Manfred already mentioned that many times. We have been using in Innovine in a range of environments. You basically, what you do is by purpose, you try to remove some of the good leaves because you want to get a delay in ripening. So by purpose, you remove some of the good leaves. It's not a mistake. It's made because you need to reach that kind of target. And tell me, I mean, the thing is, you see, since you defoliate in the upper two-thirds of the canopy, you don't really change the macroclimate at the cluster level, which is good in hot environments, for instance. But the good thing is, you see, this is how the canopy looks like after the mechanical defoliation. You basically open a window in the canopy and you remove again the most functional part of the most functional leaves. And I do see the smiling face of the driver when you tell him that he has to defoliate an area where there are no bunches around. And so he just, you know, speed ups a lot because he's basically free to go. That's a nice atmosphere. So before actually showing you an example of the kind of results you can get in the field, we also wanted to, let's say, understand what was the physiological background of this kind of technique, which was basically new, at least in terms of physiology and, let's say, practical use. And so we used the whole canopy gas exchange chamber for trying to understand what would mean removing pre-veraison or post-veraison part of the apical leaves in a grapevine canopy. And actually, this is the seasonal change in the net carbon exchange rate. So these are data coming from the whole canopy system. You see this is the control, so not defoliated vines versus defoliated pre-veraison and post-veraison. These two arrows would indicate the timing of defoliation, and you would actually notice that once you have defoliated, there is a fairly strong photosynthetic recovery or compensation from the leaves that you retain. This is surprising because, you know, you're retaining basically the old leaves, but nevertheless, we measure the consistent capacity of leaf compensation up to 25, 30%. So you need to think that even if you remove a lot of leaves, some compensation is still possible from the basal leaves that stay on the vine. And actually, when we look at the data at ripening, because the goal was basically we want to delay sugar, but we don't want to delay color. This is the major thing. And actually, when we harvested the first time, the control, which actually reached the minimum threshold of maturity, which was set at 18 breaks, you see that there was a nice delay in sugar, whereas the color was not changed. So basically, this was a hint telling us that probably we were going the right direction, right? But the problem is, if you don't try in the field, you're never sure. And so we started with some more experiments in the field. This is a trial which has been done a few years ago, but within the Innovine project, of course. And in this case, the trial was done again on Sangiovese. You see, this is done in the field. And so we open basically a window which is approximately 50 centimeters tall by removing approximately 30% of the leaf area on the vine at that time, all right? And these are the main data. You see you have defoliated versus non-defoliated, control versus defoliated over 2 years. These are the means pulled over years. And actually, we were actually able to get, a delay or a lower breaks with no significant change in color. So basically, it is confirmed that the potential of the technique is there. Of course, you need to adapt the technique to your condition. Well, the good thing about this trial was when we actually plotted the color versus time, you see, well, actually, this is color to breaks ratio, so color to breaks. You see that as soon as you do the mechanical leaf removal, you see there is a jump of this ratio. So basically, upon leaf removal, it seems that color accumulation is favored versus breaks accumulation, and this would actually last until harvest. To me, this is a fairly significant response because it really seems to mean that the leaf removal triggers this different behavior in the accumulation of the different components. Then there is a contribution from Manfred, where they actually, he already explained the treatment, so we'll go quick on that, but it is nice as they were able to manipulate the canopy, having either the apical to the bunch leaf removal, which I already explained, having a very severe shoot trimming, reducing very much the source to sink ratio, and also having the application of anti-transpirants. So with this kind of canopy manipulation, what they were able to induce was a huge variability in the leaf area to weight ratio, going anywhere from 2 square meters per kilogram in the control down to only 0.4 square meters per kilo in the severe summer pruning treatment. And major conclusions were that only the anti-transpirant treatment was actually able to lower significantly gas exchange, and in particular the assimilation rate. Intensity, timing, and positioning of defoliation were the most effective clues to alter berry ripening. The velocity of sugar accumulation was very much reduced under restricted leaf area. And more results also showed that there were no changes in pH and total acidity. There is also a higher content of yeast available nitrogen under severe summer pruning, which would be an interesting thing to discuss. And the only thing was that there was observed also reduction in starch reallocation on the severe summer pruning, as you can see from this figure here. The last example, well, not the last, but close, I was mentioning in the list of factors also the application of anti-transpirants. We already seen an implication from the group of Manfred, but we also did that. And we used 3 different treatments, spraying pinolene, which is, let's say, natural compound extracted from the pine tree, which is actually able to coat the leaf and inhibit gas exchange, partial inhibition, of course. We did, spraying at pre-flowering, pre-veraison, or at both stages. Just to show one example, you see, over the 2 years of the project, we compared, of course, the 4 treatments in terms of final breaks, and you see that especially in 2013, where the control and the early application of the anti-transpirant actually gave us a very high breaks, probably too high breaks, right? Whereas the other 2 treatments were really effective at reducing the sugar accumulation, and that was also in the cooler 2014. So the compound is indeed effective at reducing, delaying the sugaring accumulation, mostly through a limitation in the photosynthetic rate. But the good thing was when we actually plotted again total soluble solids versus color for the 2 years, there was no response this year, but in 2013 you see that there was a difference. The empty symbols are for the anti-transpirant spray 2 times a season, whereas the control is the red dot, is the black dots. You see that there was no differences in the slope, but the onset of color accumulation was actually anticipated into the antitranspirant treatments. And that was actually another good point for this kind of application. To finish, and I hope to be in time, Chairman, yeah, almost, yeah, okay, just to mention this, okay, we are really trying to postpone the whole annual cycle into maybe a cooler period, right? So one possible application is using a very much delayed winter pruning. In other words, we tried that, so you can actually try to prune your canes when you already have an average of 2 expanded, unfolded leaves on top of the unpruned cane, up to 5 unfolded leaves on top of the shoot cane. Okay, this seems crazy, but when you look at the response in terms of, delay in the phenological stage sequence, you see you have here, this is a control cluster, and this is the, let's say, late winter pruning. This is the very late winter pruning, and you see that the difference seems to be huge. And actually, we already have some field data where you have actually 2 Pinot Noir rows, where you have, colored clusters and perfectly non-colored clusters. So we need to work more on that, because it's a very delicate operation. Because you delay too much this operation, you would risk to lose basically all the yield. This has to be said, right? But it is another promising tool. Well, I think I have, this for, thanks to all the contributions to this talk. Thank you very much.